All right. Welcome, everybody. We're going to get started. So I hope everyone's been having a great conference so far. Thanks for sticking it out through day, 4 now? That's for a lot of folks, I'm sure that's been a long time. So today I'm going to talk about a bunch of services. So my name is Daniel Gickelhorn. I'm the product lead for Azure CDN and Azure Front Door services within Azure Networking. We manage basically our application services stack and content delivery stack on the edge, as well as the ecosystem of how we use that and how we measure performance across Microsoft. So today I'm going to talk about really how do you make the best use of the edge? How do you use Microsoft's experience and growing network presence to be able to make your applications and content better? How do you really focus on optimizing those applications? And really, how do you take advantage of the products that we've built in that space? So just as a show of hands here, who's used one of our application edge services like Front Door or CDN before? All right, that's a good number. Who here has, let's say, run performance tests against those services before? That's a slightly lower number. So I'm going to talk a little bit about kind of how we measure performance, as well as how you use the individual components and some of the tactics that we recommend to folks that are beneficial to do at the edge. So this is a picture. It's not actually a map. This is actually where Microsoft's global users are. When we talk about our global network, it really is there to connect all of the folks, all of the users, enterprises, devices out there to Microsoft around the world. We have about 100 million daily active users, and there's actually more than that because we can't see everybody since we shred a lot of IP addresses. But we have about 100 million daily active users. We have samples from every country on Earth, even those countries that you probably are thinking about right now. And the way we connect those users to Microsoft, to Azure, to your services, is via our global network. It starts with edge sites. So this is our global edge site presence now and plus 2 months of what's landing. This is really how we get coverage. Any places that you can see on the map where you can still see dense blue is a place where we're looking to use, basically to deploy more edges right now. And so it starts with collection. So we're a global Anycast network, so all the traffic brings into the closest edge site. And then we pull that traffic into our global backbone. And that's to get traffic onto Microsoft's network as fast as possible. That gives the best performance, and it gives us the ability to ensure there's a level of reliability in terms of taking those traffic flows across the globe or whatever distance you might need to go. We have about 130,000 miles of fiber these days. That's growing pretty quickly as we go to new markets. But functionally, this is sort of the substrate underneath how you understand networking in Azure. What I'm going to talk about today are the services that live in the little orange dots on the map here and how you take advantage of that for your apps and content. So what we hear fairly constantly in Azure from our customers when we talk to them about moving bits either in or out of Azure, it really comes down to I have a lot of customers, or I have a lot of apps that need to be internet facing and need to be secure by default. I need to be able to protect those services if they're going to be open to the internet, and portion of overall API time, especially if you have international users or you're expanding to new markets, as well as really data transaction and bandwidth costs. Getting in and out of Azure can be complex, challenging, difficult, all of that. So what we're seeing in terms of trends is really a lot of workloads moving to internet first, not always at the same speed, but really taking the journey of going from private networking all the way to public networking over time. We hear basically 3 different trends in particular, which is really we see a lot of enterprise apps moving to internet first, using auth and other tactics to lock their app down instead of private connectivity. We're seeing a lot of performance-sensitive applications really taking that leap to cloud now as they're really looking to economize and scale those performance-sensitive applications. And we're seeing a lot of changes in media, SaaS, and IoT that change the way we think about pricing models, about how do we move bits in and out of the cloud. We have a bunch of improvements that I'll talk about today about how we're adapting to meet those needs, and I'll talk about how you use those. So as I mentioned, basically we talk about sort of what are the benefits that you can get for internet-first apps, how do we address those problems, really when it comes to reliability, performance, and cost. There's a set of things that you get for free from Azure if you're building on Azure. Some of that's that global WAN. You get to use that whether you're using any of our other services or not. You get the performance improvement as we expand our network rapidly. And you get basically pay-as-you-go services from Azure. So you don't have to like commit to a 100 gig pipe or something up front if you want to really just scale your apps, your cost with your apps. So what you do need to add yourself is really all of the application logic that takes advantage of that. How do you do end-to-end SSL? How do you design your apps to use the multi-region and BCDR strategies that you can build on Azure? How do you do performance benchmarking and really figure out what's cost-effective for you to build services upon? And then the last is really how do you handle bandwidth costs and things like that? That really comes down to how you use the services and how you use Azure. So we have 3 services in our network edge portfolio today. Azure Front Door, which is really a service to be able to deliver dynamic applications, so things that don't need caching. How do you actually improve performance of things that don't need caching through the edge? Azure CDN, which is a static file delivery or video delivery platform that's scalable globally. And Azure WAF, which is attached to Azure Front Door, which is effectively how do you protect the applications going through those sites or using that service? How do you do things like IP ACLing and geo-prevention and custom rules and things like that? So the first part of that journey goes over the internet. We try to get to under 25 milliseconds to end users, and we're going very aggressive in markets like the United States to get even significantly lower than that. And then once you're using those services, if you're going to Azure regions, then you're riding that whole backbone the whole way. So I'm going to talk a little bit about those individual pillars and how do you take advantage of them to build robust architectures. So this is a pretty typical base, like sort of deployment of Front Door, is building a front door, adding a WAF to it. It's very easy to set up. You can set it up in a few clicks through the portal. Effectively, what you can do is you put it in front of, it's basically a load balancer in front of your regional services. If you're using best practices from Azure, that's really building your app with a level of AZ awareness so that you can have fault tolerance in a given region, building regional diversity both for performance and for that kind of multi-region availability, as well as making sure that your data replication story is resilient. What Front Door can add to that is, one, global anycast, which is effectively a way that we can fail over traffic so that if there's an issue on the internet, we can route around it more interactively. We give you free managed SSL certificates, so we rotate them for you and manage them on your behalf. We can also force your customers' traffic to SSL instead of having to write a redirect somewhere else. We can just make sure at the edge there's nothing insecure coming into the platform. And then especially for folks that are PCI sensitive, we can force all the traffic to TLS 1.2 so we can get rid of insecure TLS protocols and things like that on the path. With WAF, we have a managed WAF stack so that we can enable things like OWASP top 10 and basic functionality like that. And build on top of that tactics for the ability to do things like IP or geo restrictions, and to be able to add custom WAF rules, to be able to have like reactive fixes. So if you see some malicious traffic or something like that, you can go and interactively add a rule to say, hey, block this threat that I'm seeing after you start. In this middle tier, effectively, we can force SSL to the back end, which is really critical for a lot of workloads that really need a security-focused story between Front Door and their backends, as well as we do that fast global load balancing. And so if there's an outage in a given region, we can fail away from it quickly. And then one thing that we've had a lot of like scenario discussions with customers, but we really haven't gotten into a lot of depth in one of these forums before, is really you can build a DR or backup site with Front Door. So if you have large-scale websites or APIs, you can actually fail to a, let's say, static version of your website easily with Front Door and have that basically back up your site so that in case all else fails and everything else is down, there's basically a cold copy of it there for you. And then finally, because Front Door is a multi-tenant service, you need to lock your backends down so that you only get traffic from Front Door itself. So I'm going to go through a couple of these strategies today, a lot of things I've talked about in the past. Functionally, there's a lot of ease to set up Front Door, so I'm going to talk a little bit about how you set up some of these, I would say, more specific areas that folks ask us about more frequently. So fast failover with Front Door. So we ran this test, it's almost a year ago now, about what's the benefit of using a HTTP-based failover versus a DNS-based failover like Traffic Manager. And not that I'm here to rag on Traffic Manager, but the difference is that there are a lot of networks that don't respect TTLs out there. And so if you're trying to fail over traffic between two different endpoints, say when there's a failure, that long tail of traffic to converge there that sort of runs out into infinity in the timeline is part of that challenge of how do you fail over DNS. With Front Door, it's instant. As soon as we make a decision that it's bad, each individual edge node will fail over, but they'll fail over within a much narrower convergence interval. So we can fail over in about 10 seconds today, and we're working to make that shorter over time. And then a top ask that we've had around that is the ability to support head requests, because the cost of pulling your objects out of Azure can be sometimes expensive. So locking down your app to Front Door. So we get this question a lot, and so I think it's useful to go over this for a minute. So Front Door is a multi-tenant service. And so, full transparency, anybody can set up something from, in Front Door and generate traffic to anything public on the back end from Front Door's IP ranges. And so, because of that, even if you use IP ACLing, there's technically a perforation in that, which is someone else can set up another Front Door profile and access, whatever you've IP ACLed to, because the IP ACL for Front Door is a, fairly wide range, and it reflects the service overall. What we do guarantee, though, is this header called X-forwarded hosts, that will always be preserved with the hosts and the domains that you've loaded on Front Door. And so if you need to be able to create a level of isolation on the back end, in addition to just the IP range lockdown for Front Door, our recommendation is to basically look at X-forwarded hosts and ensure you validate that that's the valid host for you. This meets the basic bar for PCI compliance, and most of the customers we work with thus far. We are working over time to improve this so that there's, let's say, less interactivity to the lockdown itself. So, and then finally, that comment I made about creating a disaster recovery site with Front Door. So we provide the ability to set different priority backends. And so with those different priority backends, you can basically say, all right, so everything in priority 1 will get traffic first, but only if everything in priority 1 is down will it go to higher ordinal or lower priority backends. This is a really common use case for folks that are really trying to build something with a level of real end-to-end disaster recovery strategy, especially if you're building mobile apps or global APIs, because then you can customize what you want the response to be in the case of a disaster. It can meet the language like JSON or XML or whatever your language of choice is in terms of a failure. And you can customize it if you want to do some like geo-isolation or geo-customization or language optimization for those error messages and things like that. We have a lot of folks that even will take a static copy of a dynamic website and commit it to storage and just use that as the backup copy. So I'm going to show a little bit how you do this just for quick reference. So effectively, if you're using our portal, which if you haven't seen it, it's fairly easy to use. You set up a set of front-end hosts. Those would be your domains. Back-end pools would be basically your load balancing targets. And then you set up, effectively, routing rules on top of that tell you how to map individual paths from the front end to the back end. If you go into your back-end pool settings, you can very easily set up lower priority backends effectively just by changing this value. And so if you want to create a cold backup, it's easy to do. And we recommend if you're thinking about your BCDR strategy, it's beneficial to do from the edge as well, because we have a lot of folks that are migrating from on-prem and they want their backup not to be in the cloud or somewhere else. And so it also lets you fail over to, let's say, another cloud or something like that. So this is way low. All right. So for static content with Azure CDN, we have a recommendation. We've been having this really constant customer ask around how do I make the CDN more customizable? And one of the really great strategies there is how do you add some of your logic that's traditionally stored with storage or your backend apps, how do you move that to the CDN so that, let's say, if you're doing a migration from on-prem to the cloud, or you just don't want to have to go in and manually change all of your TTLs and other settings all the time on your content, that you can do that effectively all in one place. So we've introduced a service called Rules Engine that lets you do that. That makes it really easy to configure more of those capabilities. So, for example, in this case, I've set up a rule on my Azure CDN for Microsoft profile that, for one, forces all traffic to HTTPS. So there's a rule that says always URL redirect to HTTPS. You can do something that says, and modify a response header, like add an XCDN ID. So if you are using multiple CDNs, how do you add an ID so you can tell which one it's coming from? And then third is really if you want to add a CORS header to your response, you can do it there. And that saves you from either having to build a whole layer in front of storage to do that kind of rewrite or modification logic, or having to go all the way to the backend. Like having to manage it in storage. You can also do things like in this example, I've decided that nobody from Luxembourg should access my CDN content. Nothing specifically against Luxembourg, but it's a smaller group of people, I guess. As well as being able to do like a mobile site redirect. So we allow you to actually detect whether it's mobile or not mobile. If you want to redirect, let's say, content and say serve smaller files, smaller size images or something like that. So that's a really easy way for you to move logic to the CDN to increase your HA strategy for content. That's also a key part of building a scalable content delivery service as you roam across different storage concepts, or even if you want to make changes on the back end to say repartition your storage or blob storage or something. All right. So from there, I'm going to talk a little bit about how do you optimize your services for performance at the edge. So we generally do races on stage when we talk about performance in Front Door, where we talk about, you can get significant latency benefits through Front Door from here. My previous races, I could save about 30% of the latency if I'm just going to Chicago from here. So it's significant in terms of basically stopping SSL at the edge so that expensive communication doesn't have to go all the way back to your app server, as well as being able to use our global WAN to be able to accelerate throughput across our overall WAN. Instead of doing that, I'm going to talk a little bit about how do you measure that yourself if you're going home today, and really how do you determine the value of Front Door for your services. So there's a bunch of tactics in particular about using Front Door for performance-based failover if you have multi-region strategy, using WAN acceleration, that application acceleration by terminating SSL at the edge. But what I want to talk about really is how do you test that, right? Because Front Door has to give you value. It's something you pay for. It's an add-on service to your application. How do you make sure that performance value is beneficial? So in this example, let's say you're a company that has office in multiple locations or users around the world. Let's say you have a dev office in Seattle, like we do, and one in New York, and you're working with a partner in LA, and you're working with some vendor in what does it look like, San Antonio or something like that, and you're at the conference here in Orlando. And so you have your existing data center today, and you're trying to make a decision that say move to the cloud. performance is always one of those difficult components of moving to the cloud. And so let's say you have your own data center there in, that's about Houston, the green dot, and you're going to pick up 2 Azure regions, say, US Central, because that seems about as close as you can get to your sort of collective users, and you have a disaster recovery data center on the West Coast. So what Internet Analyzer, which we've announced this week at the conference, allows you to do is it allows you to I'm going to go through a couple things. So it allows you to effectively set up a profile and a test to be able to validate all of this. Effectively, what you do is we'll give you a link to a JavaScript asset that you can include in your application. That will effectively let you set up the test and will allow us to test from each endpoint. You give us effectively what do you want as your on-prem or your current website. This is fun. Your current on-prem website and your current website in the cloud. And we have a 1-pixel image. You can use our 1-pixel image or your 1-pixel image. And effectively, you're going to download that from each of our edge sites. And then each of your clients are going to start to send races across the globe or across to your endpoints to be able to start using them as measurement endpoints to test what that performance looks like. Once that's done, all of those measurement all of that measurement data gets uploaded to our service, Internet Analyzer, and we're going to give you effectively a scorecard for that. And so if you're looking to make a set of decisions, what we'll do is we'll give you the performance delta. Today we support latency, but we expect to expand that to other metrics in the future. And we give you the ability to drill down by country. And that allows you to really look at what are your user populations and how do you make decisions about what is the difference in performance as you're making decisions on using different services. So for example, if you're trying to do cloud migration, how do you use this to basically determine from your on-prem versus in the cloud, what's the difference in performance? If you want to use CDN or Front Door for caching or app acceleration, what is the performance benefit to your end users when you do that? As well as if you want to use it for other A/B test measurements, like if you're moving from, say, an IaaS implementation with your own VMs to a PaaS service, how do you understand what the performance changes are for those kind of service changes? So we also are expanding our POP list dramatically. So I'm not going to read all of these, but we're in a rapid expansion mode. That's also something that shows up as you run tests with Internet Analyzer. And so there's a lot of edge sites coming up in the next couple of months that are fairly noticeable that get us access to places in the world. I'm particularly excited about Egypt and Israel and getting to more locations in the Middle East. So. Before I forget, since I skipped over this, if you want to join our preview for Internet Analyzer, there's a link here that will allow you to sign up and effectively register to preview the service. It's in a managed preview right now, so that's effectively a gated test, so we can whitelist your subscriptions. So last thing I'm going to talk about and go into a little detail on is around how do you save cost with the platform. So we get this question a lot because moving bits in and out of Azure can be expensive. And how do you do that cost effectively? So one of the features that we've added that I'll talk about in a little bit of detail is how do you manage bots on the platform? So if you're building, say, enterprise apps and you don't want any bots, what we've exposed is a view into the data that Microsoft has on Internet Threat Intelligence about what are good bots, bad bots, let's say undecided bots, and how do you actually protect your service, or how do you detect that those are coming through? So if you've used our WAF product before, if you haven't, I'll give you a little bit of the overview. So effectively, Front Door has the ability to attach a WAF service to it. That WAF service runs at the edge and stops all your traffic at the edge. Policy settings will be discarded. Okay. So effectively, it lets you to set up whether you want to move into detection or prevention mode. And do you want to turn on, let's say, best practice rules like OWASP top 10 and other things like that. It gives you the ability very quickly to say enable everything. It's not going to let me do right now, but it basically enable your rules to protect you against sort of common things like SQL injection attacks, cross-site scripting attacks, and other types of path-based attacks. Many companies that we talk to use that as sort of their baseline best practice for services, is turning all of those on by default. What we've now expanded and added here are effectively a set of bot management rules. So those would be things like, why are they not showing up? There we go. Things like, how do you detect malicious bots and stop them from accessing your service? How do you detect things like web crawlers and other things that are fairly aggressive online for any endpoint? So the value of those services are really, if you have especially enterprise applications, it's fantastic to be able to just deny, let's say, all bots to your service. So last I'm going to talk about some of the improvements that we've made to cost on the platform. So we've had this asked for about 3 years now, which is why do I pay 2 data center costs if I'm going through CDN? And so what we've done is we've actually, if you're using Azure CDN from Microsoft, we've removed the data transfer charge from Azure to the CDN. And effectively makes it free for low users to add the CDN in front of anything that you have. We don't have that for other CDNs yet, but if you're using Azure CDN for Microsoft, it's really easy to add. Our goal is to have you add CDN on top of everything. That gives you the benefits of the edge directly from, without a cost penalty, effectively, to use it and to move more bits out faster. So the structure of that is, as soon as you turn it on, it won't show up on your bill. So it's not really an easy thing to demo, other than my suggestion is try it out, and it'll change the way you think about performance coming out of storage and other services if you can get CDN attached to it for free. So with that, I have a couple of go-dos, and I have a couple of things that I want to show after that. So one, if you're building that HA architecture, really you want to secure and accelerate your app with Front Door and WAF. If you're building a dynamic website, then you should use those set of default policies that come with WAF. So all of the OWASP top 10, you should turn on bot prevention. You should be ready with custom rules so that if you have, let's say, someone starts pinging your website, or you start seeing attack patterns, you can protect yourself interactively with those, because it's basically on cold standby from there. You can secure your backend by adding those IP policies, and to add those specific header protections on your backend to lock down to the X-forwarded hosts header. And our recommendation is to create a DR site, or a disaster recovery site, to be able to fail over to. And then the last is really to focus around that bot prevention of having, if you're an enterprise app, it's valuable to be able to protect yourself against bots functionally there, if you want to be able to, say, deny even good bots, because it's a cost control component. With CDN, using Rules Engine to help you scale that application and move that logic to the edge, and then to use free egress from Azure to Azure CDN from Microsoft to be able to scale out the cost elements of CDN. And the last is to use Internet Analyzer to make performance decisions about your infrastructure in Front Door, and how do you look at latency and the benefits of using any of these services. So with that, I have one more thing to show you. Which Wi-Fi and connectivity has not been my friend today. So one of the questions we get very commonly about Front Door is, how do you use it to start to compose a bigger website? Like, if you have multiple complex components of it, how do you actually stitch those pieces together? And so one of the things that I want to show is just really how do you use something like storage interactively with the rest of your front door website. And so that is fairly easy to do by just adding a backend pool and a probe so that you can make sure that we're testing that it's up. And then adding effectively a caching rule in front door to be able to cache that content in front door as well. Front door supports caching. It's really directed there for those kind of components of an interactive website like JavaScript, CSS, and things like that. You can use it to cache that content in similar to CDN, but then it's going to give you interactive failover and other things like that. So if you want to have like a hot copy of the content and still do performance-based failover, you can do that with the platform. It's very easy to set up. There's effectively a setting here called caching, and you can configure caching in front door and set up your website. So with that, that's all I have. Give me 1 second. For more information about our services, for CDN and front door, there's links there. For Web Application Firewall, there's a link to it there as well. For feedback, we love your feedback on CDN and front door. We have aliases there. Oh, and there's a link to Internet Analyzer Preview there if you want to sign up for the preview and try out that service. We have a few more sessions today and tomorrow about Application Gateway, which is how these services interact with regional services. And then how do you use services like Firewall, and a deeper dive into Web Application Firewall, both at the edge and at the region that we've unified those services. So with that, I will be up here for any questions if you have them. Otherwise, thanks a lot.